Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So we've been working with this TerraClimate Dataset or data product for the last number of video tutorials. And in general, we've spent most of our time generating images for specific time frames, and then also using a number of reducers to generate images from the image collection. For example, mean images or median images or correlation images, etc., etc. So, and also temporal difference images. And so we've, in the main, focused on images within the image collection and doing all sorts of analysis on those images, or generating all sorts of images based on a number of or several reducers. So that's what we predominantly has been focusing on. Our attention shift slightly now. Still working with the Terra dataset, climate dataset. So we will start with that dataset, but we're going to move more into time series work now, working with the data that underpins the images. Right. Remember, the images is a presentation of the underlying data. So we've just been working with the images, but now we're going to try to work with the data per se. So to this end, we are loading a number of regions of interest or locations, areas. Okay, so our traditional regions of interest is this one here, which is the you can see there, it is the vector or the shape file of my region of interest. So it's just the boundary of this specific area, and it's quite a large area itself. So that is our one that we're working there. That's our ROI that we normally use to clip all our images and our image collections, etc., etc. And then we've also included this specific file, which is 200. I think it's 200 points, randomly generated points. So this is a point file, this is a vector file. So if we look at our points, there they are, randomly generated. And this I did in QGIS. Okay, so I used QGIS to generate these particular random points. Okay, but we've also now in Earth Engine generated these points, and I think this is 1,000 randomly generated points. So we're going to go for this as well. Okay, so the first thing that we want to do is when we generate our data is to generate or to make sure that we have our point files in place. Because what we want to do is to generate data per location within our region of interest. Okay, so let me first, before I go there, let's quickly go to our standard beginning for our TerraClimate, and you'll see in this case I am creating a data set, a singular image, well, not for the whole time frame, okay, not a singular image. I am creating a variable that is my whole image collection. So that would be, that data set will contain 757 elements, and obviously I am scaling those images, individual images. Remember, scaling factor within the landing page. So that's the first thing I do, and then I give that new image collection a name, dataset medium. So this dataset medium variable here is this image collection, but scaled, okay. So yeah, so that's an important, this dataset here, this dataset 1, not the medium, that's a singular image. So this variable dataset 1 is the scaled image collection. So all 757 images scaled by 0.1. Okay. So I'm not going to use this dataset per se in my data in my time series because this is an unscaled value. So I'm rather going to use data set 1, which is the original data, but scaled by the scaling factor. Remember, I'm still working with my maximum temperatures clipped to my region of interest. Okay, and that's the broad, and this clipping tool is for, you'll see there, it is for the boundaries of my region of interest. Okay, but what I want to do, I want to use Earth Engine to create points. I don't want to first, use QGIS to create my random points. Although potentially beneficial, I would rather want to use do all the work in Earth Engine per se. So what I want to do is I have my shapefile for my region of interest, and within this shapefile or in this boundary, I want to generate X amount of random locations or random points. Okay, so what do? I first go and use this specific code to say, okay, I want to generate random points, so I'm calling this random points, and the Earth Engine algorithm or function to generate that points is simply Earth Engine.feature collection, because remember it's a table, it's a location, so that's why it's called a feature collection. Random points, no mystery there, and I'm gonna put those random points within my region of interest, and here I'm generating 1,000. These are just variables that you don't have to worry, keep it as is or just delete it. But again, you can play around with it, but it's not really significant. You can actually just ignore them. But yeah, keep it in, play with it, see what the differences are. It's not really making a huge issue at all. So by this point, I'm generating my random points using this code. Okay, I'm generating my random points within my region of interest. And then I'll just map those region points. I've unselected this this function here because I've already added it here. You see, there's the random points. So I've added that here, that map layer. Okay, so that's basically this one here. Okay, in fact, we can most probably delete it. And because, as I said, I've added that map layer here where I've done the other layers. So there's the table. Okay, and it's colored in green and it's called random points. You see, it's colored in green and it's called random points. Okay, now we can export that table. Okay, if you so wish to, we can export that feature or this table to my Google Drive, and then from there, obviously, I can do whatever I want to do with it, and I can again bring it back into it. So I can export it as a table. Okay, remember, not an image, a table. The collection, it's not an image, it's a collection of random points, which is this one here. And I'm exporting it, I'm giving it a name, I'm exporting a CSV file, I'm exporting it to my project. Okay, so you can export it, no problem. And the beauty of that is obviously then you can, within Excel, add variables to it, add data to it, and then bring it back into Earth Engine if you so wish to. Otherwise, you can just save it to your assets in general. So you don't have to first export it and then bring it in, etc. I just can save it directly to my assets. So I'm going to export the table to my assets. I'm going to the file that I'm going to export is this random points one, which is this 1,000 random points within my region of interest. And I'm giving it a name and asset ID. Okay, it doesn't have to be the same name, but whatever the reason might be, keep it the same. But I said that's totally up to your discretion. Now, when you click run, if we click run, you'll see that both these two export functions will appear in my task layout, my task. Notice your task manager here, both these two. So there's the random points. You'll see it's descriptions random points, there it is, and you'll see this one, descriptions random points dot, there it is. So both these two are now. So obviously if I click run here for my random points, it's gonna export it to my Google Drive. You'll see there, export to my Google Drive. Why? Because I've said export it to my Google Drive. And if I go with this random point touch, this one here, if I click run, you'll see it will export to my assets. Okay, and it will, there's a name that it will export to. So you basically just click run. Okay, so once it's run, it will go to my submitted task, and it will then run. It will give that little clock sign, and then once it's done, it will be, look, you know, in this blue color with the right tick. Took 1 minute to load. You'll see there it started, etc. Took about there we go, so many seconds, etc., etc. So if I go now to, let's just minimize that. If I go now to my assets and I go to, it's called random trust, so PQR. There it is. See, there it is. Let me make it a bit bigger. See, there's the random points tot. This is this 1,000 random points. Okay, so if I click on this, it will open up this little window here, and within this side of the window, it will actually locate where it is in the earth, and also it will give you a preview of how the points layer will look. The description is nothing. Features, there's a feature index. That's basically that. It's got no properties, and I can simply press import here. I can edit it if I want to, and I can add a property if I want to. I can't add features. I can have a start date and an end date, which I can change. If I go to properties, I've got a property, let's say, let's call it points, and the value, okay, so let's say add property. Okay, now just delete that property, press save. Let's see what it does. Features, property, it will just give you that. That's got nothing really. It would be nice if you can add features here, but you can't. Okay, better. So now I can just press import. Okay, so let's close it, and I go there. I can just press import here, and you'll see it will import this random touch table 2. So I've already imported it, so I'm going to delete that one there. So there it sits, okay, as a table. So now I have, within my region of interest, created 1,000 random points. 1,000 is discretionary, and I have displayed that 1,000 random points layer within my maps. I've exported it in both as a CSV file, and I've exported it as an asset. Okay, so now I've got my data set, my image collection, and I have my feature collection. I've got an image collection with 757 images, maximum temperature images for my region of interest, and I've got a feature collection of 1,000 random points within my region of interest. So I've got 2 collections now, image collection and a feature collection. Remember, my image collection I've scaled. And my feature collection, I've generated 1,000 points. So the question is, what now? What can you do with these 2 collections? I mean, I've got them now. What is my options in terms of, presenting it, estimating, calculating, whatever the case might be? What is my possibilities? And there's basically 2 possibilities, or 2 things that I'm going to do for now. Doesn't mean this is the exhaustive list, by no means. There's still lots we're going to do, but in general, there's 2 things that we're going to do, and we're going to go into detail in the next video tutorial. But suffice to say, there's the 2 things that we're going to do is as follows. First of all, we're going to generate a time series for my region of interest as a whole. So this is the maximum temperatures for my region of interest, not specific locations within my region, but my region of interest as a whole is this one. Okay, and obviously I can now, open it up and export it. Okay, So this is maximum temperatures from 1960 to the end of 2022. So December 2022, you'll see there, on a monthly basis for my region of interest. This is not a reduced time series. This is the actual 775 data points. Okay, this is my entire, but as I said, it's for my region of interest as a whole. So it's not for a specific place. Okay, so I've done that calculation. The second calculation that we're going to do is to generate time series for each of these 1,000 points. Okay, so we're going to generate a time series for each of these 1,000 points. And that will look something like this. You see, there's the 770 data points. So this is now location 1. Okay, so this is location 1. So and this is its time series. So we're going to have 1,000 of these. So this is, going back, yeah, that's a lot. So this is December 1st, January 1960, February 1960, March 1960, April, May, June, July for 1960. So this is the time series, basically this thing, this whole thing, but only for location 1. Now we don't know where location 1 is. One can go and determine where location 1 is because it does have each of these locations, these random points will have a centroid. So we can go to this random point, get its centroid, and then we can go and see where is this specific location. Okay, so that's the second thing that we're going to do. We're going to generate a time series for my region of interest as a whole, and we're going to generate time series for each of my 1,000 points. Okay, and that's why we're working within the region of interest in a boundary format, and also why we've created this random points. Now, importantly with the random points, when it comes to the random points, this one here, okay, it has to be random, so meaning this 1,000 points must be representative of the entire region of interest, meaning it mustn't be influenced by other region of interest, etc., etc. And it has to be sufficient. So if we, from this angle, it looks like, that's a lot. But if you actually drill down into the areas itself, you'll see it's fairly scattered. You'll see it's fairly scattered. Still, it's important that it's spatial analysis. It should be complete spatial randomness. Okay, complete spatial randomness, SPR. And you can test for complete spatial randomness using F statistic, the G Monte Carlo, and a quadrant analysis. So you can actually test that these values are spatially random. But we assume that they are because it's generated within Earth Engine. So yeah, so in our next video tutorial, we're gonna focus on the process of generating this data and how you're gonna be able to work with it, etc., etc. So and you see it's important we've scaled it so that the data is correct. Otherwise these values would be incorrect. You first have to correct it and then blah 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 blah. Okay, so yeah, so importantly we've generated a spatial random image or spatial random feature for our region of interest, and we're going to work with that now. Okay, thank you. A short little video, just as an introduction in future collections. And next one, as I said, we will focus on extracting the actual data and working with the data. Yeah, so that's something to look forward to. It's going to be interesting. Thanks for being with me. Thanks for joining me on this remote sensing journey. Much appreciated. Remember to like, subscribe, and to forward the video. Sharing is caring, as they say, or as I always say. And I'll see you soon. And yeah, see you on the other side.